Howdy, in the last set of videos, we were looking at simultaneous equations, and the method we used to solve the simultaneous equations was called the substitution method, and that's frequently the most easiest way to solve if possible, but it's not always a tidy way of doing it. So take this example here. I've got two equations, but I would have to rearrange one of these equations in order to make one of the variables the subject of the equation. So I'll do that really quickly so you can see what I mean. If I take the first equation and then I isolate the y by taking 2x from both sides, then dividing both sides by 3, I would get this equation, or 8/3 minus 2/3 x, either way. This is what would have to, one of these forms would have to be substituted for y here in order to solve it using the substitution method. So I hope you can see that this would be, although doable, it's a pretty ugly way of doing it. So it's not really suitable for substitution, for the substitution method. So we use a method called the elimination method. So I'll put the equation up here so we can see it again. And the elimination method relies on the principle of equivalent equations. And that means that if I take either of these equations and multiply it or divide it by any number, then as long as I'm multiplying everything, it's usually multiply everything through by that same number, the resultant equation, whilst new, has the same solutions. Okay, in other words, the same values of x and y would satisfy it. So with that in mind, what we do is we have a look at both of those equations and have a look at the pairs of variables. I've deliberately lined them up underneath each other. And we ask ourselves if we can multiply one of the equations by a value so that we get matching pairs of terms. Pause the video for a second and see if you can figure it out. Which equation and what would you multiply it by to get matching terms? Okay, so when we do that, we construct a new term. So, sorry, a new equation. So I'm going to take equation 1 and I'm going to multiply it by 2, and that will give me equation 3. So I've now got 2 times 2x, which is 4x, plus 2 times 3y, which is 6y, equals 2 times 8, which is 16. So that's equation 3. And then I'm going to write underneath it equation 2, the other one, like so. So that's equation 2. So having done that, we can now use the elimination method in order to remove one of those terms. If I just put a little, it's like doing a column add, or in this case, a column subtraction. If I subtract equation 2 from equation 3, I get this. 4x minus 4x is 0, so it's gone. 6y minus 5y is y, and 16 minus 14 is 2. So I ended up with a solution for y. Now sometimes, this is just lucky that I ended up with a single y equaling 2. Sometimes you might get, say, 3y equals 4, and then you have to divide both sides by 3 to get 4/3, or something like that. But nevertheless, once you've eliminated one of the variables, it's just a matter of solving for the other one. Now, of course, it's not complete until I find out what x is as well. So use one of the original equations, and because I've used 2 and then 3, which is not original anyway, I'll use 1 for this. So I will substitute y equals 2 in 1, and I'll get 2x plus 3 times 2 is equal to 8, and I'll just squish it into this little box here. That gives me 2x plus 6 equals 8. That gives me 2x is equal to 2, and x is equal to 1. And so our solution set, which I'll just put in this little box here, really squishy, I don't know why I'm squishing it, I've got plenty of room, is that xy is equal to 1, 2. So that's my solution for that one. So it's the elimination method. In the next video, I will go through a slightly more complex example.